Hello students, welcome back. Let's go to lesson 4, differentiation. What is differentiation? To differentiate is to find a derivative, either finding a derivative value or the derivative function. It's a verb. And the differentiation is the noun form of the same verb. So basically, we're using the derivative formulas. Remember these? That's a derivative function as a definition using Newton quotient. And then here's some differentiation rules. Constant rule, constant always becomes 0. Addition rule, derivative of the sum is the sum of the derivatives. And then the coefficient rule. We can always multiply by coefficient a either before differentiating or after differentiating. And then we have the power rule, yes, all important power rule. And the derivative of the natural exponential function staying the same. And the derivative of the natural logarithmic function becomes a reciprocal function or negative first power function. Either way, they're the same. By the way, this ddx notation means the derivative. Take the derivative. It's Leibniz notation. And if you just use prime, it's not really conspicuous. So in the starting point, I used the German expression ddx. But in the right-hand side, I'm using French expression of prime. I'm mixing those up. As for the examples, let me see. Let me emphasize this one again. Let's see, exponential function, x to the e power, and e to the x, no, e times x, excuse me, x over e. Okay, we have this kind of expression. Let's copy and paste this thing again. But this can be simplified like that. This one is all set. That too is okay. And e times x, as a matter of fact, first power is hidden, so it's okay. This one here, this one looks like a fraction, but you can rewrite like this. And of course, the first power is hidden. Highlight in green. This one is the toughest. X is in denominator. That means x to the negative first power. Let's highlight in red. And this one here, okay, all right. It's just a constant. There's no x. Therefore, if you take the derivative, let's take a little bit higher font. E to the x power, derivative of exponential stay the same. And then using the power rule, e x, and then subtract 1 from the power. Look at this brown, and that came from the power rule. Next, ex. First power is hidden, so multiply 1, and then x to the 0 power because I subtracted 1. 0 power is just 1, so there you go, and that's purple. And we get the same thing here. Multiply by 1, and then 0 power, but we don't need 0 power. So that's green. And now this one. Multiply by power, so that's negative e, and then x to the negative first power. That's red. And then we also have the sign change. Ooh, sorry about that. And then minus 0 as a matter of fact, because this is constant, no x there. But of course, minus 0, most people will just skip that, throw those away. Now in this kind of problem, it is very, very important you do not change the order. If you change the order, you lose the justification. Which term came from which term through which differentiation rule? That's not clear at all. Either you explain each one, 1, 2, 3, 4, 5, 6 of them, each one of them separately and then put them together using minimum 7 lines, or follow all this without changing the order. If you change the order, then you lose all the justification. 70% of the problem is completely gone, and the other 30%, I don't think you're going to earn the other 30% either. Maybe 1 point if you're lucky, maybe 2, maybe just automatic 0. If you just copy from a calculating tool, yeah, okay, all right. Derivative e to the x power plus x to the e power. This was negative, so all right. Plus ex minus x over e plus e over x minus e to the e power. Okay, that's what I have here. And that's the answer I got. Doesn't make sense. Which term came from where? What is the justification? I have nothing. Absolutely nothing. So if you just copy this, you don't get any credit. I'm going to regard this as a plagiarism, as a matter of fact. You just copied something else, someone else's work. Do not change the order. It's very, very, very important. Well, how about some other problems here? Well, in this kind of case, you can break up 4 of those away, and then you get a bunch of power functions. And then simplify. All right. Now you're ready. The preparation is complete. You can apply the power rule here, this rule here, and that's the answer. When your simplification takes a long time, then sometimes you get exhausted and you just end up stopping, or sometimes you mix up the derivative computation with simplification. Neither will give you much credit, if at all. So make sure that you start with the appropriate subject of the problem so that you always remind yourself that you're working on f of t, not f prime of t yet. And then, when the differentiation begins, finally, f prime of t, and then you can go to the answer, like this. Specifying what you're working on is really helpful. Left-hand side here is really helpful, even though the majority of the work is the right-hand side. Also, without the left-hand side, we do not have the full sentence. We have subject here and the verb here, equality, and the object here. And without the subject, nobody knows what you're talking about. So that's not a correct sentence. You have to have the subject and the verb. This one here, well, a bit tough, but you can work out by separating the numerator. You cannot separate the denominator, but numerator you can. And then simplify each. And that's going to give you a bunch of power functions. And then apply this rule. There you go. You have the derivative. And then we have some tangency problems here as well. Okay, all right. Those are just reviews. We just reviewed something important. No, excuse me, I take it back. Let's review a little bit more. Tangent line problem 2. Ooh, I don't have problems on tangent line, so okay, alright. I guess that's a sufficient review then. Alright. So we just reviewed elementary differentiation, the straight ahead rules of this power rule and exponential rule and log rule. And in practice, especially the kind of problems like this, these kind of problems too, but especially things are more complicated like these, a lot of additions, it is very important you do not change the order. Even in this kind of problem, you see, negative 2t cubed became negative 6t squared, and this one became that. Keep the same order so you can track down which term became what. If you change the order, you lose the definition, you lose the justification. Same goes here. If you switch things around, it's really hard to see which term, which fraction became what, which fraction became what. And then the derivative, again, which one became what, which one became what, kind of like that. Do not change the order. I know the addition is commutative, so in the end you get the same answer, but you may get credit only for the answer part, not the justification part. Okay, so much for the review, and let's discuss section 2 and section 3 in a separate video.